Hey everyone, my name is Vedrin, and in today's video we're going to continue with Layout version 3 series, and more specifically we're going to replace the Tesseract engine with EasyOCR. I'm going to show you how you can do that, and also we are going to replace the way that we are converting the HTML pages to images. We were using Selenium, which was pretty slow. So in this video, I'm going to show you how you can pre-process the whole dataset with something that is called WK HTML to PDF. And it's a library that we can use with ImageKit for Python to create the images from the HTML pages, and it works quite well, and it's quite speedy compared to the Selenium version. So in order to do that, we are going to replace some of the code from the previous notebook. So let's get started. Okay, so let's first start with the previous notebook, and I'm going to open up that. So this is essentially where we left off, and I'm going to first connect to the Google Co-op compute engine. And then I'm going to essentially, I'm going to replace some of those. I'm going to delete those two. Then I'm going to upgrade the transformers library to the latest version, which at the current time is 4.25.1. I'm going to also upgrade PyTorch whitening. And I'm going to delete Tesseract because we are not going to use it. Also the Selenium one. I'm going to upgrade Fuel. And here I'm going to introduce ImageKit 1.2.2. And then I'm going to also do EasyOCR. That's the engine that we are going to use. All right, this seems quite all right. And finally, I want to upgrade the version of GDown. And essentially run all of this. So this should go smoothly. And next, I want to remove all of this, but I want to do something else. And here we are going to use this WK HTML to PDF as discussed earlier, which seems to be Qt WebKit, which is an extension to the Qt library. And in my experience, this works pretty well compared to the Selenium approach that we had of converting the images, the HTML pages to images. So I'm going to essentially grab from this packaging from the releases. I'm going to get the version that is compatible with the current machine that the Google Co-op is offering us. And from here, I'm essentially going to take, this one. I'm AMD 64. So I'm going to essentially download this. I'm going to show how we are going to do this. I'm going to paste this. So this is essentially the link from here. This one. Then I'm going to copy it to the user bin. And from there, I'm going to just install it using the apt manager for Ubuntu, because under the hood, this machine is actually an Ubuntu. And I'm going to do this using the bash magic command. So let's run through this. And this should run smoothly. And this should download the file here. It says 15 megabytes, which corresponds to this one. It says 15 megabytes here, which is great. And now everything should be working. I'm going to remove this cell and I'm going to restart the runtime after all of the dependencies were installed correctly. And we're going to continue with the downloading of the files that we have. And the upgraded version of GDown should work correctly from here on. Yeah, and also I'm going to essentially replace the imports here. All right, so now the files are downloaded. We have it. And in here, I'm going to, basically replace the screenshot Selenium version of the dependencies. I'm importing EasyOCR and ImageKit, some fonts, and some stuff that we're going to need for the PyTorch Lightning. Of course, this will be included in the notebook after these series are completed. All right, I'm going to run through this. This should run just fine. And yeah, as you recall, we had these documents. And we have 5 different types of documents in our dataset. So I'm going to continue by taking those HTMLs. And if you recall, this is an example HTML that we are going to try to convert to images, something that we were doing using the Selenium driver. And here I'm going to basically replace all of this with the ImageKit library. So how I'm going to do this? Let's start by removing this, and I'm going to create a new function, convert HTML to image. It's going to take a file path to the HTML page. Let's call it HTML path. Then the images directory, the directory in which we want to convert the images. And also I'm going to apply a scaling to the images. So they're a bit smaller compared to the original ones. And this should help you speed up your training. And you should think about whether or not this is actually practical for you. Because most of the images that I'm converting are pretty large. And I've noticed that when you're using the OCR engines, they seems to be really dependent on how large the images are. I've tested EasyOCR. I've also tested PyTesseract or Tesseract, and it looks like the original image size is very well correlated with the output of the quality of the output that you have from the OCR engine. So you should take a look at this on your own and experiment with different scales. Keep in mind that this is actually a tutorial in which we are trying to go through the whole pipeline, and this will somewhat speed up the training process because most of the time in the training loop that we are going to create is going to be spent in the pre-processing steps. And then once we hand off everything to the GPU, the training itself or the back propagation and forward propagations are going to be quite fast. So the last parameter here is going to be the scale that I'm talking about. And by default, we are not going to scale this. I'm going to return a path from here, which will be essentially the path in which the image was saved. So how and what we are going to do here. So yeah, I have an error here. All right. So this looks all right, I guess. Yeah. So the file name from the HTML path, I'm going to replace the suffix essentially with JPEG. This is going to be the image. And the save path is going to be the images dir. Then the name of the document, class Essentially, it will be the balance sheets, income statement, cash flow, etc. And then I'm going to append the file name. Yeah, so this should be the save path. And I'm going to invoke image kit. And I'm going to call from file, pass in the HTML path, pass in the save path, and the options are going to be quiet. So I don't want any output from this because this could be very noisy. And the format is going to be JPEG. This is the default version, but still I want to be explicit here. So this should convert the file actually from the HTML to JPEG, but recall that we want to scale the image as well. So I'm going to use the PIL image, get the width and height of the image, and then call resize. This accepts a tuple for the width and the height. So, but this should be integers. I'm going to multiply the width by the scale and then do the same thing for the height. I think this should be correct. Yeah, it looks like it. And then I'm going to go image save. From here, I want to essentially overwrite the image path. And let's try out this actually. Yeah, why not? So I'm going to also delete all of this. This should be all right here. Yeah. So how we are going to test this? I'm going to take a HTML file from, let's say, this balance sheets. Let's create the path to that. Documents, balance sheets. All right. And then this one. Let's check if this exists. All right, it looks like that it does. So this will be the HTML path. So let's continue with trying out the function. We have the HTML path, and then I'm going to continue with passing the images directory. This is going to be just images. And yeah, let's call the function convert HTML. So I'm going to pass in the HTML path. Now let's move this out of the way. And then the images directory. This should also return. Yeah, we haven't called this. All right. This should also return the path to the image. So it should be here. And as you can see, we have the HTML in a nicely layout table, which is basically the final image that we have. All right. So this looks to be quite running quite well. I'm going to essentially, let's delete this file. And yeah, I'm going to not remove this, but close up this. And for each document path that we have, I'm going to call the convert HTML to image. And this is the document path, the images directory. And the scale here is going to be 0.8. Yeah, I'm going to call this like that. And yeah, this will essentially convert all of the images to this. And this should take about 12 to 13 minutes. All right, so now that the pre-processing is complete, we're gonna have a look at how the results are doing. Let's check, for example, one image. Let's check the first one. And sort the results from here. Yeah, so the images has the directory. Oh, so this created some extra directory. Let's do this. All right. So yeah, as you can see, we have an example page and everything looks to be quite all right. So let's continue with EasyOCR and how you can use it. And in this video, I'm going to just show you how you can get the EasyOCR to run. And we'll use a sample image like this in order to essentially convert and read it. So the GitHub repo is right here. It's j.ai EasyOCR. And it looks like a very well maintained project. I'm not quite sure how accurate the project is. I mean, like compared to other OCR engines, but it looks like that you can essentially train on some of your data sets with it. I haven't tried it. It might give you a much better performance compared to the out-of-the-box models that they provide. Also, they have a very nice demo right here where you can essentially upload an image, and I'm going to do just that here. I think that this should be the first one. Yeah, let's upload the image here and process it. This might take some time. So yeah, and we have basically an API documentation. They have a tutorial which shows how you can essentially call the API. What you need to do is instantiate this reader, pass in the languages that you want to add in. And in our case, is going to be just English. And then you are just pointing to the JPEG or the image that you have. And then you essentially get an output of the bounding box, the text that has been recognized, and the confidence. And for each point in the bounding box, you get X and Y. So yeah, these are the 4 points for the bounding box. Essentially pretty simple. And I'm going to show you how you can do this. Oh, right here. So this is the document that we're passing, and this is the result, as well as the number or the sequential order of words that it has recognized, because yeah, it's very important when you're dealing with those types of documents, what is the flow of the text. And as you can see here, this looks that it does a good job of that. But also you can see that some of the characters were not recognized, essentially here, 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 here. Yeah, and this is a common problem with OCR engines. And you, if you are using this in practice, you are going to hit some of those problems. But since we're doing document classifications, this might not be such a huge deal for us. But if you're extracting data from this document, then it might be a big deal. All right, let's continue with the reader. how you can instantiate it. I've shown you that you're essentially creating this reader from EasyOCR.reader. This will instantiate the reader and it's going to go ahead and download a model, which is the pre-trained model for this detection task. And then it has another model, which is essentially the recognition model. So the first one is finding the bounding boxes here. And the second one is then used to essentially read or understand or classify the characters within the bounding boxes. So these are the defaults. And if you go to the EasyOCR repo, they have an example of a new detection framework, which is DBNet 18. And you can try out this as a detector. Note that we are on a GPU machine, and this essentially speeds up the process quite a bit when you are passing in the repo. And you can know that we are almost getting 1 gigabyte of memory just by loading the reader. So we should keep this in mind when training the layout LM version model. After the reader is complete, I'm going to essentially time passing of the first document through the reader. And I'm going to essentially call the read text with the image path, and I'm going to not pass any other of the parameters, which are quite a lot, as you can see here. And you can try out these parameters and essentially have a look at how well the resulting text is compared to the one that we are getting here. And using this reader, at least, we are getting about 5.4 seconds. If I run this again, about 2 seconds. So yeah, I think that, yeah, about 2 seconds should be somewhat of a standard read per image. So keep in mind that when you're doing the training, you just take 2 seconds to convert this to OCR. Of course, you can pre-process the OCR and save the data, and this will significantly speed up the training process if you are essentially doing this for multiple epochs. So keep that in mind. And I'm going to next show you what are the results similar to what we've seen here, because it's very beneficial for you to essentially debug what is happening with the OCR for different pages. And as you can see from here, the format of this was just the bounding box. And if I go through the OCR results, you're going to see that this is essentially a list with 174 elements. So these are the results from the OCR, and let's say the first one is going to be this bounding box with this confidence, and it has recognized in lux or something like that, which is very similar to what we have here. So this is, for example, the first one, and I just want to get all of these data points and convert it into a left, top, right, and bottom bounding box. I'm going to take the bounding box data here, create the X's and Y's, and I'm going to iterate over this. Then for the left, I have the minimum of the X's. For the top, I have the minimum of the Y's. For the right, I have the max of the X's. And for the bottom, I have the max of the Y's. Left, top, right, and bottom. So this looks good. And next, I'm going to essentially plot the results of the OCR data. To do this, I'm going to create a subplot with left and right image. And on the left image, we are going to have essentially something like this. And on the right, I'm going to plot each of the words that has been recognized, because it's not just the bounding boxes. We need to have a look at the characters that the OCR engine has recognized. So I'm going to get a figure with two axes, as I already told you, left and right. And it's going to be essentially a square of a figure. The left image is going to be the image path that we got and convert this to RGB so we can visualize it. And the right image is going to be essentially a white background image. It's going to have the same size. Yeah, this will be just white. All right. So we are going to draw on both of those images. All right. And then I'm going to iterate over the bounding boxes, the word, and the confidence. Not that I'm going to use the confidence per se, but I'm going to just take it. So here, this is the bounding box data. This is essentially the index of the word. So we can plot something similar to these numbers, but it will be a bit cleaner, I hope. Then I'm going to use the create bounding box function that we just wrote. This will convert it into array. And then I'm going to draw a rectangle for each box. I'm going to put that in blue. And I'm going to add some width to it. Then I'm going to essentially expand the left, top, right, and bottom from the box. I'm going to draw the number of the word at the top right. And I'm going to do this in red. And here I need a font to do this. And I'm going to essentially show you how you can do this right now. I still don't have it, but I will show you how we are going to get it. So essentially the font is going to come from the Qt library that we have from the CV2 or OpenCV package that is included in each installation of this Google Co-op notebooks. So yeah, to get the font, I'm going to show you what is the path to this. So let me just do this for you. All right, so this appears to be working. Qt. So in here we have Qt fonts, and these are all of the available fonts that you have as a TTF files. So I'm going to essentially take this, convert it into a path, and get the Deja Vu Sans condensed font. So this should work all right. And to create a font from this path, I'm going to call the image font dot true type, pass in the font path and the size of 12. You can play around with the size, of course. That's your right, I guess. So let's continue with the OCR results. So here is the font that we have. So this should work now. And on the next one, I'm going to essentially draw out the word characters. on the left and top at the location of the word or the text of the word. I'm going to do this in black, no stroke width, just draw the text. And then for each axis, I'm going to show the left image, the right image. And for each axis, I'm going to turn off the axes or the visualization of the axes. And let's run this and see what we get. Okay. Everything appears to be all right. Okay, so this is essentially a visualization of the OCR that we have, and it looks very well laid out. Some things that you can note in here is that the results are pretty similar to the demo or the one that we saw at the J.ai page. And more importantly, you can see that the number or the layout is following what one might expect right here. Because if you have looked at, let's remove the stroke width because I don't really like it. Let's put in some more clearer text, I guess, for the numbers. All right, much better. All right. And yeah, you can also zoom in this. Oh, great. This looks all right. This works quite fine, actually. So as you can see, the layout is following somewhat of a coherent order. So this looks all right. And on the right, can I scroll this? Let me just check. Oh, okay. And on the right, you can see some of the numbers, but you're in for a surprise because, for example, you have one digit at the front that is not existent actually. And I'm going to show you this. You can't see this right here, but maybe when we go here, yeah, right here, we have another one in front of this. So this OCR is working, it's detecting some layouts, but yeah, at least from this example, it doesn't seem that it's working, that it is doing a perfect job. Of course, you might want to try and, let's say, train it on your own dataset and see how it performs. Another example is here. This one is totally missed. Let's check on the demo or the demo. Yeah, I think that the one here is also missing as well. So yeah, these are the real world results of some of the OCR engines. So guys, in this video, we saw how we can use EasyOCR to do some OCR on images. And I've shown you how you can use the WK HTML to PDF libraries along with ImageKit and convert your HTML pages to images so we can pass them to the OCR engine. We've also seen how well this EasyOCR is doing on a sample document. Of course, this might not be representative of the performance on the whole dataset that we have, but it is very reasonable to expect that the OCR engines are not perfect. Some, of course, are much better compared to others. And in the next video, I'm going to show you how you can basically integrate the OCR with the training pipeline for Layout version 3, along with the PyTorch Lightning library. And we are going to have a full training code for the Layout version 3. And we are going to then continue with hopefully Dockerizing the whole pipeline and convert it into a servable engine or servable API, which we are going to wrap in, let's say, fast API or something like that. So stay tuned for the next parts. And the notebook is going to be released once everything is complete, of course. Let me know if you have any questions down in the comments. I'll see you in the next one. Please like, share, and subscribe. Bye, guys.